Okay, in this video, we're going to be looking at Lewis dot structures, which is basically just a Bohr model, but made much, much easier. Okay, so Lewis dot structures show only the valence electrons. Okay, and what a valence electron is, these are the electrons on the outermost shell of an atom. Okay, so I only care about valence electrons because the electrons on the outside are the electrons that deal with bonding. So these are the electrons I care about, okay, because they deal with bonding. This was the Bohr models that we just did, right? If you have elements that are on your third period, or God forbid your fourth or fifth period, you're starting to get these really giant Bohr models, okay? Which is neat, and that tells you a lot about how the atom is structured and where all those electrons are. But in reality, I don't care about the electrons that are here in the inner shells. What I care about is the electrons on the outermost shell, because those are the electrons that deal with bonding. So wouldn't it be nice if for chlorine, I didn't have to draw out shells 1 and 2. I don't want to. It's too much work and effort. It takes up too much space. Wouldn't it be nice if I could just draw the outermost electrons that actually matter for bonding, right? Same thing with neon. I don't want to have to draw this inside shell. Magnesium, I have to draw 2 inside shells. Oh my goodness, so much time and effort. Okay, so instead of drawing out all of these, what Lewis dot it takes into consideration is just the outermost shell. So for example, all right, why don't we just look at magnesium, okay? So magnesium is a really good example to start with. Okay, magnesium is right here on my third period, 1, 2, 3. So I'm 3 shells in. If I was doing Bohr model, I'd have to write 1, 2, 3 shells and fill everything out. No, I don't care. I don't care about shells 1 and shells 2 because, there we go. I don't care about shell 1 and shell 2 because they don't deal with bonding. What I care about is shell 3. And on shell 3, magnesium has 1, 2 electrons. That's all I care about. So with Lewis dot, I don't even draw a circle to show the shell. Instead, I just say magnesium has 1, 2 electrons on that third shell, on his valence shell, okay? So magnesium has 1, 2 valence electrons. Easy. If I want to do chlorine, okay? Here's chlorine, okay? Again, I don't care about shell 1 or shell 2. I care about shell 3. And on shell 3, his valence shell, his outermost shell, he has 1, 2, 3, 4, 5, 6, 7 electrons. So I'm going to just 1, 2, 3, 4, 5, 6, 7 valence electrons. And there's your Lewis dot for chlorine. Okay, it's much more streamlined. It's much easier. Hydrogen. On my first shell, it has 1 electron. So 1. Nitrogen. First shell I don't care about. Nitrogen's valence shell is right here, shell 2. 1, 2, 3, 4, 5. There's nitrogen. So nitrogen should have 1, 2, 3, 4, 5. Now, if you're wondering why I'm kind of going around in a circle, all right, this is my tip to you for Lewis dot structures, all right? Big tip is to always add your Lewis dot, okay, in a circle, or like I like to think about it as a compass, okay? So like north, east, south, west, okay? So the reason we do that is because this will help you out with bonding structures when we're talking about covalent bonds, ionic bonds. If you do this in a circle, in a compass, like north, east, south, west, okay, so like top, left, right, bottom, okay, it will help you figure out where your bonds are actually supposed to happen. Okay, so I promise if you start doing this, this system now, it will make bonding easier for you later, all right? And we'll just do some random examples. So beryllium is right here, okay, 1, 2 over. So I need to have, like, go in a compass, right? 1, 2, northeast. It doesn't matter if you start up top, right? I could start down at the bottom here. Who cares, okay? It doesn't matter kind of which way you start in making your circle, just so long as you actually do that. And don't do this. Don't pair them up if they don't have to be paired up. this is bad, okay? So don't pair up electrons if they don't have to be paired up, okay? So we'll take a look at oxygen, for example, right? Oxygen is going to be in column number 6, right? Group 6b. So he's 1, 2, 3, 4, 5, 6. So he has 6 valence electrons. So if I was doing oxygen, I would go 1, 2, 3, 4, like in a circle. I've gone all the way north, east, south, west, and now I have to buddy them up, right? Now I have to pair up these electrons. So the next electron goes up here with north. So I've got a little pair here, and then the other guy is paired up together on east, okay, or whatever, right? But don't pair them up if they don't have to be paired up. So the incorrect way to do oxygen would be like this, to say 1, 2, 3, 4, 5, 6. Okay, so technically both of these show that oxygen has 6 valence electrons, right? So I'm showing my valence electrons, I'm showing my Lewis dot structure, but this one is wrong. Okay, don't do this. Don't pair them up unless they have to be. This is correct, okay? I don't want to pair up my electrons. Electrons repel each other, right? They're both negative. They don't want to be next to each other. They don't have to be. And also this will help me when I'm talking about how oxygen is going to bond to things. Trust me, okay? Single electrons will make bonds. Paired up, they're called lone pair electrons, won't. So if you just get into this habit, it will help you, okay? Next is neon. Right here, he's 8 across. 1, 2, 3, 4, 5, 6, 7, 8. So neon goes 1, 2, 3, 4. Now to start pairing up, 5, 6, 7, and 8. Okay, Lewis dot structure there. Silicon, 4. He's in group 4b. So 1, 2, 3, 4. And phosphorus is in group 5b. So 1, 2, 3, 4, 5. I only pair up those 2 at the top. All right, that's Lewis dot. It's a lot easier, obviously, than drawing out your full Bohr structure, but I think you have to understand how to get the Bohr structure before you can do your Lewis dot, okay? But Lewis dot makes things a lot easier, and it especially is helpful for bonding. All right, good luck.